In 1973, a man in Chicago bought a Marantz model 1060 integrated amplifier. It cost him the equivalent of a month's salary. Today, more than 50 years later, that machine still sits in his living room, driving a pair of speakers with the same warmth and authority it had on the day he unboxed it. It has survived 2 house moves, a family, and half a century of daily use. Now compare that to the modern hi-fi buyer. You walk into a consumer electronics store, spend €1,000 on a shiny new AV receiver with Wi-Fi, Bluetooth, Dolby Atmos, and a touchscreen app. It looks like the future of sound, but statistically, that machine will be obsolete or dead within 5 years. And when it fails, the technician will not fix it. He will tell you the repair costs more than the unit is worth. How did we go from an era of 50-year amplifiers built like tanks to an era of disposable audio electronics designed to be replaced on a 5-year cycle? In this investigation, we are going to expose the engineering compromises and deliberate design decisions hiding inside your modern amplifier and AV receiver. We are going to look at the capacitor time bomb, the HDMI obsolescence trap, and the switching power supply scandal that has quietly turned the world's most beloved audio equipment into short-lived consumer junk. And stay with us until the end, because what we reveal about the third failure point will change how you shop for audio equipment forever. The first villain in this story is the humble electrolytic capacitor. Every amplifier, vintage or modern, contains dozens of them. They are the unsung workhorses of audio electronics, smoothing power supplies, filtering signals, and storing energy. In the golden age of hi-fi, the 1970s and early 1980s, manufacturers like Marantz, Sansui, and Pioneer used large high-grade electrolytic capacitors with generous tolerances. These components were often rated for tens of thousands of hours of operation. Engineers built in real headroom. But here is what the modern industry does not want you to know. The lifespan of aluminum electrolytic capacitors varies between 2,000 and 10,000 hours depending on conditions, and a phenomenon known as drying out reduces their capacitance over time, along with their lifespan. In a consumer-grade amplifier running several hours a day, that theoretical ceiling is reached faster than any manufacturer will admit. In consumer-grade electronics like routers, televisions, and low-cost chargers, electrolytic capacitors often start to fail within 5 years due to thermal and electrical stress. Your amplifier is no different, and the situation has been made dramatically worse by a cost-cutting philosophy that has infected the entire industry. Starting in the late 1990s and accelerating through the 2000s, a wave of cheap, substandard electrolytic capacitors flooded the global electronic supply chain in what became known in the engineering world as the capacitor plague. The capacitor plague was a problem of abnormally high failure rates of aluminum electrolytic capacitors between 1999 and 2007, caused primarily by Taiwanese manufacturers using a faulty electrolyte formula that led to corrosion and gas buildup. Motherboards, televisions, and yes, amplifiers died prematurely across the world. And while the worst of that crisis passed, the underlying culture of cost reduction never did. Today, the capacitors in a budget AV receiver are selected not for longevity, but for price per unit. Engineers who have worked on amplifier restoration report that most capacitors begin to measurably deteriorate after just 4 to 5 years, though their rated life may appear longer on paper. When specialist-grade replacements were sought for restoration projects, minimum order quantities made individual replacement economically unthinkable. The result is an amplifier that sounds fine on day one and begins a slow, invisible decline that you may not even notice until the day it simply refuses to turn on. But the capacitor problem is only the beginning. Here is the first thing we want you to keep in mind as we go deeper. The failure mechanism we are about to describe next is not a flaw that manufacturers are trying to fix. It is a feature that was engineered in. The second catastrophic failure point in your modern amplifier is the power supply itself. In the great integrated amplifiers of the 1970s, machines like the Sansui AU9500 or the Pioneer SA9500-2, the power supply was built around a large, heavy toroidal or EI core transformer. This was an inelegant, expensive, and magnificent piece of engineering. Toroidal transformers are often used as crucial power supply components in audio equipment because of their high efficiency, low electromagnetic interference, and compact size, and their design generally brings higher sound quality without vibrations. These transformers, paired with large filter capacitors, created a reservoir of clean, stable power that could handle the dynamic swings of music without flinching. A well-built transformer of this era could last indefinitely. It has no moving parts, no electrolyte to evaporate, and nothing to degrade. It simply works. But today, in pursuit of slimmer enclosures, lighter shipping weights, and lower manufacturing costs, the industry has largely moved to switching power supplies, or SMPS. Switching power supplies are becoming more common in audio equipment because of their efficiency and lightweight design. However, they can introduce more noise into the audio signal. That noise is not just an aesthetic problem. A power amplifier driven by a switching regulator is apt to have undesired radiation resulting from amplified, high-frequency ripple components, and the output signal from the amplifier can be distorted by these ripple components. The engineers know this. They know that the warm, effortless sound of a great analog amplifier comes in no small part from the stability of its power supply. But a switching supply costs a fraction of a toroidal transformer, and it allows manufacturers to shave kilograms off the chassis weight, which reduces shipping costs. They traded your listening experience for a cheaper freight bill. Now, here is where it gets truly sinister. And this is the second thing we want you to hold on to. Even if the capacitors hold out, and even if the switching power supply keeps running, there is a third failure mechanism that will render your modern AV receiver completely useless. And it has nothing to do with any component physically failing at all. Your modern AV receiver is not just an amplifier. It is a computer. It processes HDMI signals, decodes Dolby Atmos, streams music from the internet, and runs firmware that must be updated to remain compatible with the devices around it. And this is where the industry has found its most elegant and profitable form of planned obsolescence. In 2020, Denon, Marantz, and Yamaha launched new AV receivers with HDMI 2.1, marketed as future-proof and ready for 4K at 120 Hz. Within months, it was confirmed that these receivers could not correctly pass 4K/120 Hz RGB signals. A chip-level analysis concluded that the HDMI 2.1 implementation was faulty by design, and that a firmware fix might not be possible. Customers who had paid premium prices for premium products were told their best option was to connect an additional adapter box, another piece of hardware, as a workaround. Sound United, the company behind Denon and Marantz, acknowledged the issue, but was seemingly unable to find a permanent fix, offering instead an adapter kit 6 months after launch. This is not a story about one bad chip. This is the story of an industry that has built a fundamental obsolescence cycle into the heart of its products by tying audio hardware to a video connectivity standard, HDMI, that changes every few years. Your amplifier from 2018 does not support EHRC. Your amplifier from 2020 cannot reliably pass 4K/120 Hz. Your amplifier from 2023 will not support whatever comes next. The root cause is that receivers are made on the cheap, with a lot of amplifier channels crammed in around complex processing circuitry. Devices this complex should have a modular design which would give people a realistic chance of having their units serviced or upgraded. Instead, when one part of that complex system fails or becomes obsolete, the entire unit becomes a candidate for the bin. Compare that to a 1973 Marantz Model 1060 or a Sansui AU 9500. These machines have no HDMI port. They have no firmware. There is nothing in them to become obsolete. They amplify an audio signal, and they do it with solid iron core transformers, carefully selected transistors, and components chosen for quality rather than quarterly cost targets. They can be serviced. Every component is accessible, replaceable, and still available from specialist suppliers. The capacitors can be refreshed for a few €100, and the result is a machine that performs as well today as it did 50 years ago. The newer amplifiers cannot afford to use the same quality of components as the good vintage amplifiers due to the cost of those high-grade parts. The vintage designs were built for analog music and featured serious, dedicated phono stages, something modern equipment increasingly omits or implements poorly. So what is the solution? The answer depends on what kind of listener you are. If you genuinely need surround sound and HDMI switching for a home cinema setup, buy the cheapest AV receiver that does what you need today, and accept that it is a temporary tool like a smartphone. Budget accordingly, and do not be seduced by premium finishes on what is fundamentally disposable technology. But if what you care about is music, real 2-channel stereo music, then the answer is to stop buying into the modern game entirely. Seek out a classic integrated amplifier from the 1970s or early 1980s. A Marantz Model 1060, a Sansui AU 9500, a Pioneer SA 9502, a Kenwood KA 7100 from that era. Have it properly serviced by a qualified technician, new capacitors, new contact cleaner on the controls, fresh thermal paste on the output transistors. For a few €100, you will own a machine built with the kind of honest engineering that the modern industry has completely abandoned. It will not stream music from your phone, it will not decode Dolby Atmos, and it will absolutely still be working in 2050. The industry has been selling you the idea that newer means better and that complexity means quality. It does not. It means more things that can break, more software that can stop being supported, and more reasons to go back to the store in 5 years. Do not let them tell you that your perfectly good amplifier is obsolete, and do not keep buying their engineered junk. If this investigation opened your eyes, we have one question for you. Do you still own a piece of vintage hi-fi equipment, or have you already replaced it with something modern? Let us know in the comments. We read every single one. And if you believe more people deserve to know the truth about what they are buying, a thumbs up and a subscription to this channel cost you nothing but means everything to this investigation. We will keep digging.